Hello students, the topic is all pairs shortest path or Floyd Warshall algorithm. So, how are we going to solve this problem? I will explain it to you. Let's suppose that we are going to find the all pair shortest path from the vertex 1 to 2, 3 and 4, or we have to find from the vertex 2 to the vertex 1, 3 and 4, or from the vertex 3 to the vertex 1, 2 or 4, or from the vertex 4 to the vertex number 1, 2 or 3. See, this is how somehow related or similar to the single source shortest path, that is Dijkstra algorithm. But in the Dijkstra algorithm, we were using the one single vertex as our source vertex, and then we were calculating the shortest path to all the other vertices. Here we have to calculate the shortest path for every pair of the vertices, right? So if we run Dijkstra algorithm here, Dijkstra algorithm runs n square times, n into n times. So the all pair shortest path will run for n times. So the time complexity here will be n cube for the all pairs shortest path. Now how we can also solve this problem using the greedy method, but here we will use the dynamic programming to solve this problem to find the all pairs shortest path. So first let us understand the problem. In the problem you can see that we are given 4 vertices 1, 2, 3 and 4. Then we are given a matrix A naught matrix, or we can say that this is our zero matrix, right? So here we have taken the diagonals as 0, 0, 1 to 1, 0, 2 to 2, 0, 3 to 3, 0, 4 to 4, 0. Why we have taken these diagonal values as 0? Because 1 to 1 there is no distance traveled, or we cannot apply the loop over here. 2 to 2 there is no distance traveled, or no, we cannot apply the loop over here. Same is the case with the 3 and 4, that there is no distance traveled to itself of the vertex, and we also cannot apply the loop on it. So that is why we have taken the 1 to 1, 2 to 2, 3 to 3, 4 to 4, or the diagonals as 0. Next, understand the problem further. The distance 1 to 2 is here, you can see 1 to 2 is 3, this one. So we have written 3 here. 1 to 3, there is no direct path, right? So we have written infinity there. 1 to 4, 1 to 4, there is no direct path from 1 to 4, so we have written infinity there. Again, same is the case with the 2 to 1, the distance is 8, and in the same manner we have filled our matrix. So we have to solve this problem by taking some decisions. How to take those decisions? Let's suppose I am having two matrices in a problem, that is 1 and 2. The direct distance is 8, but in the other case I am having another matrix here, and the cost from 1 to this one is 2, and from this one to this one is 2, and I am getting the cost as 2 plus 2, that is 4. So it is less than the direct cost, that is 8. From here I am getting 4 cost via the adjacent matrix. So I will take the cost from that I am getting from the adjacent matrix, that is 4. So this is how I am going to take the decisions. We are going to take or make the decisions by simply making the matrices. Now let us so we will use this matrix, that is our zero matrix, or the A naught matrix, in order to draw our further matrices. Like we have drawn our matrix A1 here, right? So the first row and column of, if we are drawing the matrix 1, the first row and column of our matrix will remain as same. So we have written it as it is if we are going to make the matrix A1. Then we will calculate the rest of the values and fill our matrix. That is, the first one is 2 to 2. So what is the formula for that? The formula is that, and we will also take the diagonals as 0, right? So the formula is that you have to take the A naught, whatever is the distance we are going to find. We will use the matrix, the previous matrix, in order to find the current matrix values. The previous matrix is A naught, right? So the distance we are going to find, that is 2 to 3, right? On the other side, we will take A naught. We will use the intermediate node in between of it, like this. That is A naught 2 comma 1, distance from 2 to 1, plus A naught, distance from 3 to 1. So if we take a look at the A naught matrix, the distance from 2 to 3 is 2, and on the other side, to our right side, the distance in the A naught is 2 to 1 is 8, and 3 to 1 is infinity. So which one is less, smaller one? That is 2. We will consider the smaller one. We will write it here, right? So next we will, if we are going to calculate the distance for 2 to 4, here we will use again the same formula, that is A naught, whatever we are going to find on the left side, A naught, we will use the intermediate point in between of it, that is 1, A naught, distance of 2 to 1, A plus A naught, distance 1 to 4. So the distance from in the A naught 2 to 4 is infinity, and the distance A naught 2 to 1 is 8, plus A naught, the distance of 1 to 4 is 7. So 8 plus 7 is 15, and this is infinity. So which one is smaller? 15. So we will consider this smaller value and we will write it here. So the distance from 2 to 4 is 15. Right? Now we will again do the same procedure for the other values, that is 3 to 2. Right? So here we will get the value as 2, right? You can see here we have find out the value, and the value here is 2. So the next one is, you can see, that is 3 to 2. A naught matrix, we are going to find this one, distance 3 to 2. So we'll check it in the previous matrix, and to the right side we will use the intermediate node in between of it, A naught 3 to 1 plus A naught 1 to 2. So we will check in the A naught matrix the distances. So 3 to 2 is infinity, and 3 to 1 is 5, 1 to 2 is 3. So we will add it, 8 and infinity. So 8 is smaller, so we will write it here. Consider the smaller one. Now we will apply the same steps and fill the rest of the matrix, that is 1, 8 and infinity. So this was all about how we can make our matrix 1. Now we will use this matrix 1 to fill our matrix number 2. So in the matrix number 2, the row and column will remain as same as the matrix A1, and the diagonals will remain as 0, and then we will find out the rest of the values, right? So now we will use the matrix A1 in order to fill the values in the matrix A2. So the first value is 1 2 3, A1 1 2 3, this is what we are going to find, and then if we are going to construct our matrix number A2, then the intermediate node will become 2, right? So here we will use the intermediate node 2 in between of this. So on the left side, whatever we are going to find out, this is the distance we have to calculate, a1 1 2 3, right? And a1 1 2 2, we have just used the intermediate node in between, plus a1 2 2 3, we will check the distance in the a1. So 1 2 3 is infinity, 1 to 2 is 1, to 2 is 3, and 2 to 3 is 2. So we will add these both. On the left side we got infinity, on the right side we got 5. Which one is smaller? 5 is smaller. Write it here. We'll consider the smaller one. Now again we will do the same to find out the next value, that is 1 to 4, a1 1 to 4, a1 1 to 2 plus a1 2 to 4. Check what is the cost of the distance in the a1. 1 to 4 is 7, 1 to 2 is 3, and 2 to 4 is 15. Add these both. Which one is smaller one? This is smaller one. Write it down in the matrix 2 in the distance 1 to 4. Right? So this is how we can fill our rest of the matrix, that is 5, 1, 2 and 7, using the same approach or the steps. Now we will use this matrix 2 in order to create or construct our matrix 3 and then use its values to fill the rest of the values of the matrix 3. So when we are going to construct our matrix 3, the third row and column will remain as same as the matrix number 2, A2. So here you can see that we have taken the same values in the matrix A3 as they were in the matrix A2, and the diagonals will remain also 0, 1 to 1, 2 to 2, 3 to 3 and 4 to 4. These diagonals will also remain as 0. And we will find out the rest of the values using the values of the distances of the matrix A2 in order to complete all the rest of the matrix A3. So we will use the formula, that is A2, as we will use the distances of the matrix A2 to complete the matrix A3. So the first one we have to calculate distances, that is 1 to 2, right? So we will write A2 1 to 2. We will just use the intermediate node in case of matrix A3 or the third matrix, that will be 3. 3 will be the intermediate node. So we'll just use it in between. A2 1 to 3 plus A2 3 to 2. So 1 to 2 in the A2 is 3. 1 to 3 in the A3 is 5. 3 to 2 is 8. Add them both, 13. Which one is smaller one? 3. Consider the smaller one. Write it in the matrix A3. The distance from 1 to 2 is 3. Right? So this is how we calculated the distance. Now we will apply the same steps in order to complete our rest of the matrix, to find out the rest of the distances in the matrix A3, that is 6, 1 to 4, that is 6, 2 to 1, that is 7, 2 to 4, 3, 1 to 4, 2 and 4 to 2, that is 5. So we will use the same formula, same approach, same steps to fill out the rest of the matrix A3. Now we have to create the matrix A4. In the matrix A4, the intermediate node will become 4 and the fourth row and column will remain the same as they were in the matrix A3. So 2, 5, 7, 0, 1, 3, 6. 2, 5, 7, 0 and 1, 3, 6. The matrix, the fourth row and column will remain same as they were in the matrix A3, right? And the diagonals 1 to 1, 2 to 2, 3 to 3, 4 to 4, they will also remain same because there is no distance cover and we cannot apply the loop there, right? And then we will calculate the rest of the distances using the matrix A3 and using this formula. So the first distance we have to calculate is 1 to 2 for the matrix A4 or the fourth matrix. So A3 1 2 2, and on the right side A3 1 2 3 plus A3 3 2 2. So what is the distance in the A3? 1 2 2 is 3 and 1 2 3 is 5, 3 2 2 is 8. Add both them. Which one is the smaller one? 3 is the smaller one. Consider the smaller one. Write down here in the matrix A4. 1 to 2 distance is 3, as we have considered the smaller one, right? In the similar way, now we will calculate the next value, like that is 1 2 3. We will use the formula to calculate that is 5, and in the similar way we can fill up the rest of the matrix. The rest of the distances we have calculated are from 2 to 1, that is 5, 2 to 3, that is 2, and 3 to 1, that is 3, and 3 to 2 is 6. So this matrix will give us the all pairs shortest path, right? So this was how we calculated the all pairs shortest path. We took some decisions, and how we made these decisions, we used these matrices to make such decisions. We drawn different four matrices, and then we take decisions. We took the smaller distances in each of them matrix. So this was all about the all pair shortest path Floyd Warshall algorithm.